Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at nested template classes in C++. So I thought it would be interesting to see how to implement our own enhanced for loop in C++ to implement a class that supports it. Although actually I should really call it a range-based loop because this terminology is more common in C++. So I want to show you how to implement a class that supports a range-based loop. And to do that we need to implement some kind of collections type class. So I thought we could implement a ring buffer class. So a ring buffer or a circular buffer or a cycle buffer is some kind of area of memory which you can write to. And when you get to the end of it, if you keep writing, it starts writing to the beginning. So this is often used in multimedia applications because you can write to the buffer and you can read just a bit ahead of it. And when you run out of memory, instead of stopping, the read and write pointers just kind of cycle on around the same bit of memory. So we'll take a look at an example of how this works. You'll see how this works as we progress. But in this class I want to start by showing you how to nest template classes because we're going to need that to implement our iterator syntax. So let's right click the project here and go to new class. Now normally I prefer to follow the convention of giving classes an uppercase first letter, but I want to emphasize a similarity here with the STL built-in classes. So for that reason in this particular project I'm going to follow the convention of giving classes a lowercase first letter. So whatever convention you follow, you should follow it consistently within one project. And I'm going to follow this different convention here. So I'm going to call this ring. Let's click finish. Now because we're going to implement a template class, and because there's no non-hacky way to put the implementation of a template class in a separate CPP file, we're not going to use it. So I'm going to delete the CPP file and we're just going to stick with this ring.h here. Let's maybe get rid of these, the constructor and destructor, and start from scratch. So what we want to have here is we want to be able to say ring, declare a ring, and pass it a template type like string, for example. And let's call this text ring. And then we want to be able to add values to it by saying text ring. And for example, we can implement a method called add. Now, when I instantiate my ring buffer, I want to specify the size of memory that it's using. So let's give it a constructor argument, and I'm going to say that if I specify, for example, 3, it's going to mean that we can specify maximum 3 of these in the buffer, so 3 strings. So if I call add 4 times, let's add 1, 2, 3 and 4. I then expect this 4th one to overwrite the 1st one, and if we add another it's going to overwrite the 2nd, and so on. So the buffer is a circle where the end is kind of connected to the beginning, and if you keep adding data it just starts writing at the beginning. Now I'd like to be able to iterate through that and see it. So we should be able to do, before we implement the range-based loop, we should be able to do something like this. So let's say for int I equals 0, while I is less than text ring dot size, I or plus I, and then we should be able to do cout text ring.get I, and that should return as the string. And if we run this program and we saw the output from it, we'd expect to see 423 because the 4 has overwritten the first element in the buffer. Actually you could implement all this stuff as far as I can see. Yeah, you could implement all this stuff just using the stuff you've seen so far, especially if you've seen my beginners C++ course, which is free. you could already implement this. So it's a really good exercise at this point to stop the video and see if you can implement a class that behaves like this. So the output should be like this. Output should be 4, 1 and 2, because the 4 overwrites the 1. So if you want an exercise, stop and just have a go at that, see if you can implement it. And we're going to go on to implement it now. To start off with, I want to tackle what's perhaps the most possibly the most strange aspect of this. So initially, let's simplify this a bit. Let's comment all this stuff out. So I'm going to go to source and add block comment. So let's aim to implement something really simple. Just initially, what we're going to look at is how we can get syntax like this. So ring string colon iterator it, and then we could set that to, for example, we could set that to text ring dot begin or whatever if we've got an iterator of the right type. But the question is, how do we go about implementing this? So let's initially simplify this, because we don't need this for this stuff here, but we're going to need it if we want to implement our own range-based loop. Let's get rid of the template parameter initially, so we've simplified it a bit. How would we actually implement that? Well, that's pretty simple. So let's go to ring.h here. Let's make sure that we include it in our project here, in our main function file. Let's go to ring.h. So we've got a class ring, and C++ allows you to declare classes basically wherever you want. So we could say class iterator like that. And let's just give it a method just to test it. So let's say public void print, and if I include iostream up here somewhere, let's say include iostream and using namespace standard, then I should be able to get this to work. I should be able to say hello from iterator. We don't need this print method, but I'm just putting something in to help demonstrate the concept. Then if we, that looks like it should work. So let's take a look here. So we've declared a value of type iterator. You see that iterator is nested within ring. So to access the iterator type, we use this kind of syntax here, 2 colons and then subtype there. Then we should be able to say it.print, and that ought to work if we've got this right. So let's go to build project and run it, and we see hello from iterator. So that works. This syntax is widely used, but in general, usually this is not good practice. The reason being one of the reasons being that the nesting level is going to get really deep here. If you're going to implement a lot in this subclass, it's going to end up looking pretty ugly, and you end up sort of not knowing whether this method belongs to the ring or the iterator or what. It gets confusing to look at. So we'd like to be able to take the implementation outside the class, and it turns out it's very easy to do that. Let's copy this class here. Let's move it outside like that. Format the code, and then all we need here is sort of like kind of looks like a forward declaration of the class, although it's not, but all we need is class iterator, and that means that this type is a subtype of this. And then where we specify this class here, now because this is not a freestanding class, because it's nested within the ring, we need to specify here ring colon. So this looks like a normal class declaration, except that we've put the ring colon here, and we've put just the class iterator bit, the name of this class, within class ring. We've made it public so that it can be accessed from outside. And if we do that and we run it, it works just as before. So doing this having that there and having this bit here with the class definition has allowed us to do this stuff here. If we wanted, we could go on and separate out the implementation of this. So we could, let's copy that, and we could paste it in here, and we could say void ring : iterator : print. Just have the prototype of it here, format that code, and run this, and it still works. So so this also works, and we've got to have extra colons in here to specify how the class is nested. But with template classes, with our template class here, it's we're not going to do that, because to separate out the implementation would be tricky and involve some hacks. So we're going to implement everything kind of in line in the header here, rather than separate out the actual implementation of the functions. But we do want to still separate out the actual class, because it's just a lot easier to read than having a whole class nested within another class. Now the next challenge here is ring should be a template type. We should be able to specify some kind of template parameter there, but we don't want to specify a template parameter to iterator. Nevertheless, iterator here has to be able to work with the template parameter, because, for example, later on we're going to want to say stuff like cout dereference the iterator. So that's an overloaded star dereference operator, and this should return the type that we specified here to the outer class ring. So iterator has to be aware of the template parameter of ring. How can we actually make that work? Well, let's get rid of that for the moment. Let's go to ring.h. So ring has to be a template class. We need to say template class T. And by the way, something I want to mention here is that instead of using class there, you can also use type name. It works just as well. Some people prefer it because the template value you specify here isn't always a class. It might be a primitive type like int. So in a way, type name makes more sense, but probably the most common convention, possibly, I'm not sure, is that we type class there. So I'll stick with this. Now, the ring, okay, now we've made the ring a template class, but the iterator, that's also going to be a template class, but we don't want it to have its own template parameter. We want it to use this one. So in fact, we're going to have to also specify template class T here. And what we do is we put this T in the ring bit like this. An iterator can now use that class T, but we're not forced to specify the template parameter separately to the iterator, because we don't want to here. So now if I run this should work. And indeed, just to prove that ring can use this template type, let's do something like we can output a blank T, whatever it is. So let's run this. That's not going to really show us anything, because an empty string is no use. This is going to run the default constructor of whatever type this is. And if we go to our main function here, let's try an int, because the default constructor of an int will initialize it to 0, so we should expect to see 0 there, and we do. Might be slightly nicer if we had a colon. So using this as a base, we can work forward and implement more features in our class. In the next tutorial, we'll go ahead and give this class some methods, and then we'll move on, possibly in the next tutorial, or maybe even the one after that, to looking at implementing the range-based loop. But so what I'd suggest is have a go, certainly, at replicating this syntax. So remember, the end goal here is simply to get this to work. That's the end goal, and to do that, we have to do this. Make sure you separate out your inner class iterator from your outer class ring, or whatever you care to implement, because that's good practice. And if you haven't already, if you want to have a go at implementing a ring buffer class that would enable you to do this, then that's also an interesting challenge to look at. And we're going to look at implementing some of these methods in the next tutorial. So that's it for this time. Until next time, happy coding.